Number 16, we're looking at a mass difference / E equals mc squared type problem. So what we'll do first is figure out the mass difference. Now the mass difference is going to be the sum of the mass of the products minus the sum of the mass of the reactants. Now when we do that, it's going to be 4.18 12 plus 5.1511 minus, and you'll notice I put the products and reactants in square brackets here. I haven't quite got enough room there, so we'll do 3.1121 plus 6.3916. And that comes out to be negative 0.1714 AMU. So all of those are in AMU. The number of significant figures here, these are all 4 decimal places, or 4 places past the decimal. So our answer comes out to be 4 places past the decimal as well. So that's the mass in AMU, or the mass difference. You'll notice it's a negative value. We expect it to be because we lost mass going from the reactants to the products. The products were less mass than the reactants, essentially. So what we can do now is we can apply our E equals mc squared equation here. The mass is going to be what we discovered. You'll notice I'm taking the negative sign off here because the mass is going to get translated into a positive amount of energy. Leaving the negative sign on would indicate that energy was released, and that's okay, but I'm just going to take that off and just leave it as a positive. So we've got 0.1714 AMU. We know how many kilograms there are in AMU. That's 1.6605 times 10 to the negative 27 kilograms. You'll find this in an old test or in the notes, this conversion factor. And then 2.998 times 10 to the 8th meters per second. That's the speed of light, and that's all squared. And then to get it into kilojoules, or joules per mole in this case, it would be times 6.022 times 10 to the 23. And the unit on that is moles to the negative 1. So that's everything in a mole. Now the thing is, the AMUs will cancel. We're left with kilograms and meters squared per second squared, because all of that gets squared. And all of that equates to a joule. So the answer we get for this is going to be 1.540 times 10 to the 13th joules per mole. The per mole, of course, comes from over here. That's the unit on the Avogadro's number. But we need gigajoules per mole per the question. So we need to convert that into gigajoules. We do that by using the conversion factor given to us. And we know that 1 gigajoule is equal to 1 times 10 to the 9th joules. And that will give us 15,404 gigajoules per mole. Taking this down for significant figures, it would be 15,400, because this would be 4 significant figures to match the 4 significant figures we've got over here. And that was 4 significant figures because we got that from the mass here.